Welcome back to another exciting episode of Dave Does Math from Home. Today we're talking about, this isn't my favorite section. As sections go, it's pretty mediocre, but it has the best name of any section. Today we discuss vectors in space. I always want to do that. Okay, that's done. Vectors in space is pretty exciting. All the vectors that we talked about in the last video, in section 13.1, were planar vectors. They happened in the xy plane, they look like points. Today, we're going to talk about vectors, what those things look like when you add another dimension. And honestly, it's kind of boring. As a two-dimensional vector, v equals 3, 4, is this point 3, 4, or it's not the point, it's the vector that goes from the origin to 3, 4. There's v. As a, let me use a different letter. As a vector in 3 space, 3, 4, 5, the first two things mean the same thing. This is sort of like the x coordinate, this is sort of like the y coordinate, just like this, only now we're adding a z coordinate. We are leaving the plane behind, and now we are doing things in 3 space, 3 dimensions. So you can still have an x here and a y here, and this vector will still be on the xy plane. The projection of this onto the xy plane would still be here, except because of this, it's going to be 5 units above the xy plane. It's going to be right here. If you did 3, 4, 2, it would be closer. If you did 3, 4, 10, it would be further out. If you did 3, 4, negative 6, that would be behind the whiteboard, 6 units back past the whiteboard. So yeah, it's just, we add a third dimension, you add a third number in your vector list. Everything else about them stays the same. We can still find the magnitude by taking the square root of all of the pieces squared. So this time it'll be the square root of 50, which is 2 root 5, if you want to simplify it. No, 5 root 2. 5 root 2 is the simplified version there. So you still find the magnitude in the same way. You still can double this in the same way, or I've doubled a lot of things. Let's see what happens if we multiply this one by 4. 4u would be 12, 16, 20. That's 4 times this vector. So all the math pieces still work the same. We could still add 2 vectors together if they have the same dimensions. In this case, we cannot add these 2 things together because they are different sized vectors. This is a 2-dimensional vector, this is a 3-dimensional vector. Those things are incompatible. There's no way that these 2 vectors can interact with one another. So we're not even going to try. But if you have 2 different vectors that are both the same number of dimensions, like if we erased this one, came up with a new vector v, like 13, negative 2, and 8. Now we could add these things together. U plus v is 16, 2, and 13. So we can still do all of this arithmetic just like normal. There's just a third piece involved. Analytically, this doesn't make much difference. Like, we're doing the exact same things with a third number now attached to the end, and all of it works the same. The big conceptual jump here is visualizing what these things mean in 3 space. When we did vectors in the plane, we could visualize them very easily. They're just, you can draw that arrow on the plane. It's very nice. When we do these vectors here, this, I can't even really draw the point, because the point is 5 units like above the XY plane. If this whiteboard is the XY plane, the Z axis is what's coming straight out of it towards the camera. So the point is above 3, 4, 5 units above 3, 4. So the vector is going to be this sort of pointed in this direction. So this is a great time to talk about a couple things in terms of 3D visualizations. First of all, I am, for the most part, incapable of drawing three-dimensional things. When you do some homework assignments, you'll see a lot of times they do this. Here's the Z plane, here's the Z axis, here's the X axis, and they'll like have the Y axis sort of like coming out at you like this. Like the book tries to do this a lot, and then you'll have things like -2 on the X axis and 3 on the Z axis, and it'll come out in the Y axis another 3 units. So you'll have this point like right here. It's above that, and over here. I can't do that well in any capacity. It's extremely difficult for me. So in these videos, I'm kind of just not going to do it. I will gesticulate wildly, and I will point at things with pens in various directions to try and indicate what's happening, but drawing it is not going to happen in these videos. Other people have been very successful in creating 3D visualizations of these things. The homework is one of them. They do things like this pretty clearly, I think. There's other YouTube videos or channels you could try, or other just Google image searches you could hit up for these sort of things. Do whatever you need to do to be able to effectively visualize these things in 3D. The second thing I want to say is the way that I have been describing this case so far is with the XY plane on the surface of writing, and the Z-axis coming out of that surface. That is naturally how I think about these things. So when I'm on the board, X is right, Y is up, and Z is coming out at the camera. Positive Z is towards the camera, negative Z is behind the board, away from the camera. That is how I think of these things. If you are sitting at your desk writing this, then sort of the perspective shifts a little bit. X is still usually to the right, Y is like away from you, and Z is like up off of the paper towards your face. That's naturally how I think of this. That's how I'm going to describe it when I talk. Obviously some other places do it differently. Some places try to draw the XY plane as a literal horizontal plane and then draw the Z-axis up on, still like on the surface of writing. It all gets kind of messy. So familiarize yourself with the way I do it, because that's how I'm going to sort of talk about this and describe this most of the time. And when I deviate from that, I will be very clear that I'm deviating, and find some visuals that you can reference that will help you. And the homework assignment for this section does have a lot of those visuals attached. Only part of this section is actually about vectors. A big part of it is just about starting to learn how to visualize these things in 3 space. So I'm going to sort of shift to talking about that, because there's really nothing else I need to say about vectors, I think. It all works exactly the same as in 3.1, except for the thing that I forgot to say in 3.1. Okay, wait, pause. Let me talk about that, and then we'll switch to some 3D visualization stuff. So, the thing that I forgot to mention in 3.1, I need to mention here, and the other thing that is going to be relevant here is these triangular brackets that we have, 13, -2, 8. This is one way to write vectors. There's another way to write this vector, and it is as a sum. we could call this 13I, I would say negative minus 2j plus 8k. And sometimes these i's and j's and k's get little hats. I usually leave off the hats. These are the sort of things that in the textbook they appear bold, which means they're vectors. This is a nice way to write these vectors because I and j and k are sort of like the fundamental unit vectors of 3-space. And if you're doing 2-space, it's just I and j. I means it means 1, 0, 0, which is the same as 1 unit right. Right, or the positive x direction. J is the unit vector 0, 1, 0. This is 1 unit. Up, which is the positive y direction. And k is 0, 0, 1, which is, I think of this as 1 unit out. So like out off of the surface of writing. And this is the positive z direction. So writing this as a sum and difference of some multiples of i's, j's, and k's is just another way to write this if you don't feel like writing these triangular brackets. And this information applies to section 3.1 as well. I think a couple of the 3.1 questions are going to ask you about writing vectors in terms of I and j. So there's no k in 3.1 because that's all on the plane. K is what happens when we move from the plane to space. But the same idea is here. I's, j's, and k's instead of triangular brackets. This way of writing it, I think, makes it easier to do some calculations. Like if you're looking at this and you're trying to wonder what 2v is, I think this is much more clear that you can just distribute the 2 into these 3 things. Or if you're adding vectors, you just add like terms. So hopefully this makes it more clear what you're dealing with. If not, write it this way. It's kind of up to you. I have no strong opinions about how these things get written. With that, I think I'm going to shut this video down, and then I'll start another one so that we can start talking about all the 3D visualization stuff you're going to encounter in section 3.2.